Hello, in this lecture series, I will cover whole integral equations. The book which I had referred is M.D. Rai Singhania. First of all, we will know what is integral equations and classification of integral equations. In our junior classes, we have studied linear equations. What was that? That was given some constant variable and the relations, we have to find the value of that. As we grow later, we studied linear equations in two variables. In class 9th or 10th, we had studied quadratic equations. In 11th, 12th, we have studied differential equations. What was quadratic equation? Quadratic equation was equations having in x or y which have degree 2. Okay. In differential equations, there was an equations involving the term of differentiations. Examples: dy by dx plus sin x equal to 0. But now today I will teach you what is integral equations. Integral equation is not something like differential equations or quadratic equations. Okay, suppose integration of sin x. Here integration contains, but this is not integral equations. There are certain rules for integral equations, which is an integral equation is an equation which an unknown functions appears under one or more integral signs, and there can occur other terms as well. See, an integral equation is an equation in which an unknown function appears under one or more integral signs, and there can be other terms also. The standard form of integral equation is this: yx equal to fx plus lambda a to b integration kx comma t yt dt. Here see, what this function is in x, this function is in t, so we cannot integrate it easily. Therefore this is called integral equations, and there are various methods to solve the integral equations we will study later on this stage. Here see, yx, fx and kx comma t are known functions. This value will be given in questions. And x and t belongs to from where? Closed interval a comma b. Lambda a and b are constant, and yt is unknown functions. Okay, and kx comma t is known as kernel of integral equations. This is known as kernel of the integral equations. Now let us have a look with an example. Yx equal to x square plus 1 x square plus x plus integration 0 to 5 x plus t yt dt. See, here fx is x square plus x, lambda is not given, it means what? 1, a equal to 0, b is equal to 5, and kx comma t kernel is x plus t. Note, if this fx is equal to 0, then homogeneous equations, then this integral equation is called homogeneous, and if fx is not 0, then non-homogeneous equations. I hope you all are aware about what is integral equations. Now let us have a look on types of integral equations. There are mainly two types of integral equations. One is Fredholm integral equations and second is Volterra integral equations. What is Fredholm integral equations? Fredholm integral equation is nothing. Integral equations where this a and b are constant, a and upper limit and lower limit are constant, such type of integral equations are called Fredholm integral equations. Let's have a definitions. The equation of the form gx into yx fx plus lambda integration a to b kx comma t yt dt, where a and b should be constant and x comma t belongs to closed interval a comma b. This type of integral equations is called Fredholm integral equation. Example: x square yx equal to 2x plus lambda 2 to 4. See here, this is constant and this is constant and rest all is same. Here gx is equal to x square, fx 2x, a is equal to 2b is equal to 4, and kernel of this integral equation is x square plus t square. Okay. Further, Fredholm integral equation is classified into two types. There are mainly two types of Fredholm integral equations. There is some other types also, that is third types. I will also have a look. A Fredholm integral equation of first kind. The integral equations, Fredholm integral equations in which gx is equal to 0. If gx is equal to 0 in the standard form of Fredholm integral equations, then the resulting equation is of first kind. Okay. Example: 0, all are same. Fredholm integral equation of second kind, where gx is equal to 1, Fredholm integral equation of second kind. And there is also Fredholm integral equation of third kind, where gx is not equal to 0, not equal to 1. Other than these two values, if gx occurs, then this is called Fredholm integral equations of third kind. Sorry. If gx is equal to 1 in the standard form of Fredholm integral equations, then the resulting equation is called Fredholm integral equation of second kind. In next lecture, we will cover what is Volterra integral equations. Thank you.